In this video, we're going to take a look at solving a hypothesis test about a proportion. So this is from your homework from section 10.2. So a certain drug can be used to reduce the acid produced by the body and heal damage to the esophagus due to acid reflux. The manufacturer of the drug claims that more than 93% of patients taking the drug are healed within 8 weeks. In clinical trials, 220 of 233 patients suffering from acid reflux disease were healed after 8 weeks. Test the manufacturer's claim at the alpha equals 0.05 level of significance. So the first step is to take a look and make sure that all the conditions or requirements are satisfied. So the first, to make sure that n times p naught times 1 minus p sub 0 is equal to 15.2. So in this case, n is equal to your sample size, and our sample size was 233, and p with the subscript 0 is your null hypothesis value, or what we're testing against, and the claim is 0.93. So taking it 233 times 0.93 times 1 minus 0.93 is where the 15.2 came from. That's greater than 10, so that requirement is satisfied. The sample size is less than 5% of the population, as 233 patients suffering from acid reflux is a lot less than 5% of the population of acid reflux sufferers, and the sample can be reasonably assumed to be random. So the requirements are met. So the null and alternative hypotheses, the null hypothesis, this is a proportion, p is equal to the claim of 0.93, because that's the standard that we're measuring against, and the manufacturer, the alternative hypothesis is p is greater than 0.93. So this is the test that we want to take a look at. So in the calculator, we're going to run our test in the calculator, and what the calculator output is going to give us is the test statistic, and it's also going to give us the p-value. So let's go ahead and run the test on the calculator. So let me bring that up. So the calculator, let me scoot it over so we can see it. We go to Stat, over to Tests. This is a proportion test, so it's a one proportion z test. All of the proportion tests will be z-tests. Hit enter. So the input that we need for the one proportion z-test is we need the null hypothesis. For this problem it's 0.93. We need x. X is the number of successes out of your sample size. So in the clinical trials, 220 out of 233 patients suffering from acid reflux. So our x is the 220, and our n is the 233. Then the test that we're doing is greater than, and we go ahead and calculate. So the results, the output that the calculator gives is the z is your test statistic. So the test statistic z, bring that back up, z is equal to the 0.849. That's where this 0.85 comes from. And then the p-value is 0.1976. Okay, so how do these all relate to each other? So I guess that's one of the things that we want to know. So when you go back to the test, there's also an option to draw. So let me get back to the one prop z test that we just did. Down at the bottom you see an option draw, so that you can tell what we're doing. Okay, so how this works is this normal distribution goes with the null hypothesis, so 0.93 is in the middle. And then our sample was 220 out of 233, So that proportion lands here. And what that means is that if it's 0.85 basically standard deviations away from the mean. And the question is, the reasoning is that unusual enough to say that it's different from 0.93? Is it really greater than? Or is it not far enough away from 0.3 to say that? That's significance level. So if the significance level is 0.05, that means that right here is a cutoff. And that cutoff would be your critical Z. We're going to find that next. And if your sample landed more to the right and your p-value was less than 0.05, you'd say, oh wow, it's really unusual. But it didn't. The p-value is 0.1977. That's the probability that if it's really 0.93 that you got the result that you did. So your result is not unusual. So that's the reasoning behind the hypothesis test. So let me close the calculator for a second. So when we're determining the test statistic, okay, so we've got that tells you that based on your sample is 0.85 standard deviations above 0.93. Okay, the critical value, the critical Z, if we were going to do this by hand, the Z is the cutoff that goes with your significance level. Our significance level alpha is 0.05. This is a right-tailed test. So your critical Z, there's only one of them because this is a one-tailed test, is the Z-score that goes with that. So to find that, use the inverse normal like we did in Chapter 7 to find it. The area to the left is 0.95. It's a standard normal, so mean of 0, standard deviation of 1, and that's how you find the critical value. So it's not something given to you when you run the test, but it's something that you can find. So let's go to distributions. We're looking at inverse norm because we're finding a Z-score that goes with an area. The area 0.95, it's the area to the left because that's how your calculator reads it, even though it's 0.05, mean of 1, standard deviation. And that's where we get the value of 1.65 for determining the critical value. Okay. So the last part of the question is choosing the correct conclusion. Alright, I don't think I can scroll this down. So what the conclusion is, it's failed to reject. And what that means is our value from our sample landed here. Our cutoff for significance was stated at 0.05 here. So we didn't make it that far. It's not far enough away from the 0.93 to call it unusual. So we're going to fail to reject the null hypothesis. That means there is no evidence. There's not evidence that, what did the drug claim? The drug claim that more than 93% of patients taking the drug are healed. There is not evidence that more than 93% were healed. Okay, so it's not far enough away. All right, I hope that helps with the reasoning and how to find a critical value.